Okay, so in this video, I'm going to show you how to calculate correlations using Stata. So first off, you'll see that I've got Stata already opened, and I already have data loaded into Stata. And just as background, this data set is every public school in the state of New Jersey in 2018-19. So this is school level data. And so the first thing when you're doing any sort of statistical analysis is to know what kind of variables that you're working with. And so there are sort of two common correlations, calculations that you might use. And again, just so what a correlation tells you is the strength and direction between two variables. So by direction, we mean is that are higher values of one variable associated with higher values of the second variable, or lower values of the second variable. So that's what we mean by direction. So a positive correlation means that higher values of the first variable are associated with higher values of the second variable. A negative correlation would be higher values of one variable are associated with lower values of the other variable. So that's the direction. And then magnitude or strength is how strong that correlation is. So that's what a correlation is. And so to do that, you need to know again what kind of variables you're working with. Most of the time, so if you're working just with continuous variables, you'll use a Pearson correlation. And so that's what I'll show you first. The second option, though, that is sometimes used is if you have ordinal data. So let's say you have data where it's sort of categorical, but higher categories mean more of something. So for instance, letter grades, with an F being a 1, a D is a 2, an F is a 0, a D is a 1, a C is a 2, a B is a 3, and an A is a 4. So that's an example of an ordinal variable. So if you're using ordinal variables, then you would use Spearman's correlation. So I'll start by showing how to use Pearson correlation, which is most commonly used. So again, Pearson correlation is when you're looking at two continuous variables. And so let's say that what we want to look at in our data, so this is school level data, and let's say that we want to look at, say, third grade ELA and math scores, right? So I've got one variable here. So ELA means score 3. So I'm just going to click this little button here to put it down into the command line. And then I need to scroll down a little bit further to get to math, mean score 3. So to do this, we just use the pairwise correlation command. So it's PWCLRR. Then the two variables that we want to use for our correlation. And then we want to use two options, which are obs, which will show you the number of observations used to calculate that correlation, and then significance, which is going to return a p-value. And so what we get is this table here. And so it's important when you see a table like this is knowing which cells to interpret. So you'll see that these two variables these two cells are exactly the same, right? So it's a correlation of 1, 448 observations, correlation of 1, 448 observations. So that's because this is for ELA, average ELA score, average ELA score. So obviously those are going to be the same. So you don't interpret those, you ignore these cells. Then obviously you also ignore this blank cell. But what you would interpret is in this cell right here. So this tells you three things. So there's the correlation coefficient, which can range from -1 to 1. So this tells us direction and magnitude. So it's positive because it's greater than 0. So this is a positive correlation. So higher average schools that have higher average ELA scores also tend to have higher average math scores. And we'll see that it's very close to 1. So this is a very strong relationship. So this is a very strong and positive correlation. The next line here in this cell is our p-value. So this is a 0.0000. So this is obviously much lower than the significance threshold of 0.05. So we would conclude that this strong positive correlation is statistically significant. And this uses 448 observations to do that. So that's all there is to it, to do a Pearson correlation. If you wanted to use Spearman, I actually don't have ordinal variables that I could use here, but it's pretty easy to do. So the code for that anyway would be to use, it's just Spearman, and then variable 1. Oops, there's no comma, my mistake. Variable 1, our second variable, and then our comma, and then we just want to use the stats option. And then in here you just type rho and p. And so that would tell you the correlation coefficient and then the p-value. So that's all you would need to do to calculate a correlation of two ordinal variables. So that's all there is to it.